Greetings of the day. In this session we are going to discuss the impact test on mild steel, aluminum brass by means of IZOD test. Experiment number 6, impact test on mild steel, aluminum brass by IZOD test. Aim: to determine the impact strength of mild steel, aluminum and brass of given specimen by IZOD test apparatus, pendulum type impact testing machine, vernier caliper. Reference: IZOD introduced IZOD test in 1903. Test is as per the IS 1598. Theory: in an impact test, a specially prepared notched specimen is fractured by a single blow from a heavy hammer, and energy required being a measure of resistance to impact. Impact load is produced by a swinging of an impact weight W, hammer, from a height h. Release of the weight from the height h swings the weight through the arc of a circle, which strikes the specimen to fracture at the notch. In that kinetic energy of the hammer at the time of impact is mv squared divided by 2, which is equal to the relative potential energy of the hammer before its release, mj, where m is the mass of the hammer and v is equal to 2gh is its tangential velocity at impact. G is gravitational acceleration, 9.806 ms2, and h is the height through which hammer falls. Impact velocity will be 5.346 m, or slightly less. Here it is interesting to note that height through which hammer drops determines the velocity, and height and mass of a hammer combined determine the energy. Energy used can be measured from the scale given. The difference between potential energies is the fracture energy. In test machine, this value indicated by the pointer on the scale. If the scale is calibrated in energy units, marks on the scale should be drawn keeping in view angle of fall and angle of rise. Height hone and h2 equals. Ona is equal to r in bracket, one minus cos theta, and h2 is equal to 1 minus cos theta. With the increase or decrease in values, gap between marks on scale showing energy also increase or decrease. This can be seen from the attached scale with any impact machine. Energy used in fracturing the specimen can be obtained approximately as 1 minus watt 2. This energy value called impact toughness or impact value, which will be measured per unit area at the notch. IZOD introduced IZOD test in 1903. Test is as per the ES 1598. Mounting of specimen is clamped to act as vertical cantilever with the notch on tension side. Direction of blow of hammer is shown in figure. Direction of blow is shown in figure. This is the diagram. In this direction of blow and direction of blow of hammer is shown. Procedure 1. Measure the dimensions of a specimen. Also, measure the dimensions of the notch. 2. Raise the hammer and note down initial reading from the dial, which will be energy to be used to fracture the specimen. 3. Place the specimen for test, and see that it is placed center with respect to hammer. Check the position of notch. 4. Release the hammer and note the final reading. Difference between the initial and final reading will give the actual energy required to fracture the specimen. 5. Repeat the test for specimens of other materials. 6. Compute the energy of rupture of each specimen. These are the observations. Weight of hammer, that is W, equal to 21.926 kilograms. Length of hammer, that is R, equal to 0.825 m. Angle of fall. Alpha equal to 90 degree. Area of specimen below the notch, which is equal to 6 millimeters, multiply by 10 millimeters, equal to 60 millimeters square. And observation table shows that different materials such as steel, aluminum, and brass, angle of fall, initial reading and final reading, energy absorbed, impact strength, angle of rise, and impact velocity. And then we'll get different reading for different materials. Sample calculation. For steel, impact strength equal to energy absorbed divide by area below the notch, equal to 242 by 60, equal to 4.033 joule per millimeter square. For aluminium, impact strength equal to energy absorbed divide by area below the notch, equal to 22 by 60, equals 0.366 joule per millimeter square. For brass, impact strength equal to energy absorbed divide by area below the notch, equal to 18 by 60, equal to 0.3 joule per millimeter square. Sample calculation. For steel, impact energy equal to WR, KOS beta minus CO alpha. 242 equal to 21.926 into 825, COS beta minus cos 90. After calculating, we get beta value, which is equal to 89.26 degree for aluminium. Impact energy equal to WR, Chi beta minus Co alpha. 22 equal to 21.926 into 825, KL as bat minus cos 90. After calculating, we get beta value, which is equal to 89.93 degree for brass. Impact energy equal to WR, QS beta minus cos alpha. 18 equal to 21.926 into 825, A's ba, Azabad minus cos 90. After calculating, we get beta value, which is equal to 89.940. The formula for impact velocity is under root 2 gr in bracket 1 minus cos alpha, and after calculating, we'll get impact velocity equal to 4.023 meter per second. Finally, we will get the results in form of impact strength of different material. First, impact strength of steel specimen is 4.033 joule per millimeter square. Second, impact strength of aluminum specimen is 0.366 joule per millimeter square. And third, impact strength of brass specimen is 0.3 joule per millimeter square.